All right. So as we begin, remember your first paper dealt with trying to calculate either a volume of a gas, or the number of moles of a gas, or the mass of a gas, depending upon whether it was at STP, which would have been all of them. And what that means is not all gases will be measured at STP, and that's where the ideal gas law is utilized then. So, on page 384, okay, the ideal gas constant is which variable does it say in that paragraph? The letter R, okay? Did a bunch of pirates come up with that? R, R. I sound like a pirate and I smell like one. Arr. Okay. Pirates. Letter R. So where that comes from, okay, look at these constants, okay? Just either cover your eyes or look straight ahead. Okay. This is not, you're taking STP into account. But so ideally what that means is, what pressure would that be? 1 atmosphere. What would the volume be? 22.4. What would the temperature be? Yeah, you take all them into account. You divide 273 then into 22.4, and it gives you 0.0821. That's where that constant comes from. Okay, so what is taken into account is 1 mole, which, remember the example, we would always say, okay, here's a container. I've got 32.06 grams of sulfur in this container. So what do I have as a counting unit? Look at element number 16. What's inside that box? It doesn't say 1 mole on there. Give me what it might say in element 16's box, besides 16 and S and sulfur. Why is 32.06 important? Right. So if you have 32.06 grams of sulfur in this container, you've got 1 mole. Right. So when you're dealing with 1 mole of a gas, taking into account 273 degrees Kelvin and 22.4 liters in 1 atmosphere pressure, that gives you that constant of 0.0821. So here's another equation for you, which is the pressure of a gas times its volume equals the number of moles times the constant times the temperature. Okay? Yes, this is worksheet 2. All right, so what we want to do, well, maybe you don't want to, but what we're going to do, yes. I wouldn't look at it that way. Don't say 1 mole equals that. No. Just the only thing we want you to know is the constant R. We don't say 1 mole, don't say 273, don't say 22.4 liters. Once you start throwing them factors in, you're going to confuse yourself.
So R is 0.08.
Yes. That's all we want you to know about R. Okay? Now, it's a little different if something is measured at STP, but not all gases are measured at that. And that's why we utilize the ideal gas law. Okay, so on page 385, okay, there's a sample problem. You can read on your own, but the practice problem number 1. It says, what pressure in atmospheres is exerted by 0.325 moles of hydrogen gas in a 4.08 liter container at 35 degrees centigrade? Now, let me ask you this. This is going to be a trick question, perhaps. How could we, what's the variable for N? We just said what it was. Number of moles. let's say you were not given part of that information. We'll circle around to that. So you were given, you're looking for the pressure because you don't know. You were given the volume. You know what R is, you know what N is, and you know what T is. Okay? So when we provide that information, it says 35 degrees Celsius, but we don't want it in Celsius. We want it in what? So how do you find kelvins? Don't you look for someone named Kelvin? Kelvin. Kelvin. That too? That works? Kelvin. Oh, okay. Is that good? Okay, so 35 plus 273 gives you what? Is it 308 maybe? I don't mind. Okay, it was a lucky guess. You believe that?
No.
What do you believe then?
You've done it before, and you did it in your book, or you did it in your head or something.
Oh, okay. I got some people buffaloed then. Okay, so what's R then?
0.0821.
It's always going to be that value. Okay, what's volume then?
It's 4. Wait, are we on that problem?
Uh-huh.
Practice problem?
4.08 liters.
Okay, so I know.
Okay, but like I said, we'd circle around to this. What if it said in that problem you had 4.08 grams of hydrogen as well? They don't give you the N variable, but could you find it?
Yeah.
Okay, so what is so if we had, we're just going to use this as an example, if we had 4.08 grams of hydrogen, how are we going to get that for that variable? We got 4.08 grams.
You have to divide by 1.01.
I got 1. I got 2.
Oh no, hydrogen's right now.
I got 2 people who fell in the trap. Who,
It's 2.02.
who's lost when we say that? Who fell in the trap? You maybe caught yourself. Someone over here said 1.01. Okay. Okay. So why is that a trap? Because remember, gases are diatomic. This is probably one of the number one mistakes that people are going to make. They're going to put 1.01. It's human. You're just human. You're not perfect. Okay? But if it's a mistake, 2 things we want you to do. We've heard this over and over. Try to learn from them and try not to repeat them. That's right. Okay. That's the spirit. Okay. So we're given 0.325 moles then. So once you have all these variables in there, I can just tell you it's 2 atmospheres. Is that what you got? Okay. 2.49. That I don't think that would be correct. Okay, so
I got 2.01.
that's what we want. Okay. Now, when you look at this, just like when you're doing Boyle's law, Charles's law, the combined gas law, it's one of those aspects to where, yes, once you get everything fit into where it goes, it's pretty simple. But this is kind of a little different because if you are given the number of moles, it may say find the mass, or it may give you the mass of a gas. You have to find the moles to put into the equation. And what that means is remember what all those variables stand for. So when you're solving for this, you've got 4.08 V equals, okay, was it 308 times 0.0821 time, darn, I ran out of space, 4.08 V. And this is why we're not too concerned with your label. 325. Okay, so this is mole. This was degrees Kelvin, and then of course this was atmosphere. And then this is labeled has the liters on top, kelvins on the bottom, as atmospheres and liters and moles and kelvins. Okay, so typically what happens with your algebraic skills, that cancels that one, that cancels that one, and then this one is canceled by that one, and then all you're left with is liters. So that's why we're not too concerned about all the labels for that. Okay. So again, it probably doesn't seem that bad, but in some of these problems, again, I can't stress this enough. They may not give you the number of moles. They're going to give you a mass, and you have to find the moles first. Let's see here if they have something like that. If there isn't one in here, I guarantee you there's probably at least one or two of them on your papers. Let's maybe take a look at the back of the chapter, and I'm still looking, and I'm not seeing one right off the top of my head here. Because I'm looking in the mixed review and other problems as well. We'll come back to that at a separate time. Okay, I was kind of hoping I could find one right off the bat, but it's just not happening. Do you want to do number 2, or is that something you'd rather work on for yourself? Okay. And if you're wondering what you get, somewhere around 4 for number 2. 3.98 or somewhere close to 4.
When we do fresh acid, we have to do it in atmosphere.
Yes.
So if it's asking what is the pressure in kilopascal and temperature,
You're gonna have the answer or pressure given. In this case, we said it was 2.01 atmospheres in practice problem number 1. Okay, so what that means, okay, is if you want it in kilopascals, what is it that we need to do for this conversion? Say that again. 101.325 kilopascals for every atmosphere. Yep, that's correct. And I think there is a video that was provided that actually went through one, because I think it deals with nitrogen. That was in a presentation that was done on Sunday. So, not that YouTube may have seen that. If you had actually watched or went to the Science Channel and seen that. Yes, March 10th. Yes, yes. It was kind of difficult because the makeshift whiteboard I had was kind of annoying, but he said beggars can't be choosers because it was taped to the wall and it kept flapping back and forth.
It was like 4 of them?
4 of them taped together. Yep. All right. So barring no questions, the rest of the time will be yours. Okay. What we want you to do is turn in worksheet 1 tomorrow and have, I should have said today, see if I can give you a heart attack, right? Try to have worksheet 2 done by next Tuesday. All right? And then we'll probably start gas stoichiometry at some point next week. And that's when the fun begins. That's what I've been telling you all semester long. That's right. Okay, we will catch up to you next time.